Good morning, students. Dear students, as you are knowing that we are continuing with our chapter 4, that is motion in a plane. And during the discussion of motion in a plane, in the previous video, that is part 5, we had discussed about the various properties of addition of vectors, and in that we had discussed about the resultant of the vector, what is the magnitude of the resultant of the vector, how to find the magnitude of resultant of the vector. After that, commutation followed by the vectors we had discussed. After that, we had taken the cases, that is when two vectors are parallel to each other. If they are parallel to each other, that is theta is equal to 0 degree, then what will be the value of resultant? When two vectors are anti-parallel, theta is equal to 180 degree, then what is the value of resultant? And when the vectors are perpendicular to each other, that is theta is equal to 90 degree. In this case, what is the value of magnitude of the resultant? Then we had find the resultant angle of resultant vector with the horizontal vector, that is 5 we had calculated. After that, we had discussed about the various position of vectors. When two equal vectors, how two equal vectors will be equal to 0, how two more than 2 or 3 vectors is equal to 0, when the vectors will be non-coplanar, then how it is equal to 0. All these things we have discussed in the previous video. Now, based on the studied concept what we had studied in the part 4 of the video lecture, we will solve certain numericals, and after that a very important topic, that is resolution of vector, we will study in today's video. So let us start the session of today's video, students. So dear students, look at the numerical first, which is in front of you, and it is a very good numerical, very conceptual numerical, and try to understand what the numerical is saying. It is based on the vectors. What is the displacement of the point of a wheel initially in contact with the ground? I will draw the detailed diagram based on the question. I'll try to make you understand about the question. So where displacement of the point of a wheel initially in contact with the ground. This is a wheel, and this point of wheel is initially in contact with the ground. When the wheel rolls forward, what is the direction? X-axis is the forward direction. It is given in the question, X-axis is the. When the wheel rolls forward, half revolution. Half revolution means what? This point comes in contact with the ground and this point goes upside. So this is the half revolution. Means this point becomes here. Half revolution. Then what will happen? This distance is what? This distance becomes pi into r. Half 2 pi r is the whole. If it will revolve whole throughout, then 2 pi r. So half revolution, this distance will be pi r. And this is the radius r. This distance will be the radius r. So horizontal distance will be pi r and vertical distance covered is r. So now it is easier for you. These things are known, then you can easily find the value of resultant. If it is representing one vector and it is representing other vector, then you can find this vector based on the. And what is the angle between these two factors? These two factors angle is 90 degree. Then on the basis of magnitude, r vector is equal to under root p square plus q square, you can find the value of resultant vector, and similarly you can find the value of this resultant, what it is, angle phi. So I am making the detailed diagram and then try to solve the question. You can also, by pressing the pause button, you can also solve this question by yourself own, but I am also solving this and giving the solution to you. Look at the solution, students. During half revolution, look at the diagram. First of all, see the diagram. This is point A, this is point C, this is point B, this vector, and suppose this is Q vector, this is P vector, and this is R vector. This angle is phi, and this is as is given in the question, and this is x-axis. During half revolution, point A covers pi r, that is equal to AC. This distance will be pi r. This is horizontal distance, and BC, that is vertical distance, and it is equal to, vertical distance is equal to r. So we can write it as magnitude of AC vector is equal to magnitude of V vector, and this is equal to pi r, and magnitude of BC vector is equal to Q vector, and this is equal to r. This is equal to 2r, and this is equal to 2r, and theta is equal to 90 degree. Theta is equal to 90 degree. Now magnitude of r vector is equal to under root p square plus q square. So magnitude of p square is equal to under root pi r whole square, and q vector is equal to 2r whole square. Now look at here, students, dear students, it is r under root pi square plus 4. This is the magnitude of resultant vector. This is the magnitude of this resultant of these two vectors. And as you know that result formula for resultant p square plus pq square plus 2pq cos theta, and theta is the angle between the two vectors. This is 90 degree. Now we are interested to find out this angle, what the resultant is making with the p vector or horizontal vector. What the resultant is making an angle of horizontal vector. What the resultant is making an angle with horizontal vector or p vector. So you know that formula, tan theta is equal to q upon p. Tan theta is equal to tan phi tan phi is equal to q vector upon p vector. Magnitude of q vector upon p vector. and magnitude of q vector is twice of r, and magnitude of p vector is pr. R to r cancel, then tan phi is equal to 2 upon pi, and from here we can have phi is equal to tan inverse 2 upon pi. So this is all about this numerical. In the given numerical we have find the resultant as well as the result, what the angle the resultant is making with the horizontal vector. Now look for the second question. Look for the second question. We will try to solve the question. First of all, dear students, look at the numerical in front of you. You have to guess about, you have to find about vectors A and B. What type of vectors are vector A and B, which are satisfying the first relation mod of vector A plus B is equal to mod of vector. So dear students, we have to find out the relation between these two vectors, vector A and vector B, which are satisfying the relation mod of vector A plus B is equal to mod of vector A minus B, and second thing is vector A plus vector B is equal to vector A minus vector B. So try to solve this by yourself. I am also solving this and explaining you also. So the solution of first part is, that is vector A plus vector mod of vector A plus mod of vector B, and this is equal to what? This is equal to A square plus B square plus 2AB cos theta. This is the resultant, the magnitude of resultant of these two vectors, and it will be A square plus B square. Now mod of vector A minus vector B, it can be written as A square plus B square minus 2AB cos theta. Now according to problem, this is equal to this one, so we can say that under root A square plus B square plus 2AB cos theta is equal to under root A square plus B square minus 2AB cos theta. Squaring both sides, you will get A square plus B square plus 2AB cos theta equal to A square plus B square minus 2AB cos theta. Like terms will be cancelled out, and if it is transferred to this side, then it will become 4AB cos theta, which is equal to 0, and from here cos theta is equal to 0. And can you say that when the value of cos theta is 0, according to trigonometrical analysis, we can say that theta is equal to pi by 2. Means from here we can say that A and B are orthogonal vectors. Means from here we can guess that vector A and vector B are orthogonal vectors. Vectors A and B are orthogonal vectors. Now for the second case, when vector A plus B is equal to vector A minus vector B. Second case, that is part B, vector A plus vector B is equal to vector A minus vector, it will cancel, sorry students, it will cancel out, and it is equal to twice of B is equal to 0, and vector B is equal to 0. Vector B is equal to 0. From here we can say that vector B is a null vector. Vector B is a null vector. Vector B is a null vector, and vector A, if B is vector, from this equation vector A is a equal vector. Vector A is a equal vector and vector B is a null vector. So this is about the numericals, students. Now one most important topic we will discuss and try to understand it, because it is very much important for further calculations in further chapters also. So, and I will also make you clear it, a resolution of vectors. A resolution of vectors, as very much clear from the name resolution. A resolution means what? To resolve. To resolve. And what is the meaning of to resolve? To resolve means to say that, suppose there is anything, there is two bread pieces. Suppose there is one bread piece, there are two bread pieces. Bread pieces, and you had combined it to make a single bread. Single bread means you had resolved the single bread into two pieces. Now when you are joining these two pieces, you are getting the single bread. In a similar way, if there is a vector in two dimensions, then it can be resolved into two fragments. It can be resolved into two fragments, because if it is in two dimensions, it must be possible that they have two components in horizontal and vertical direction, whose sum gives the value of this resultant R. If this is the vector in three-dimensional space, then it must be resolved into three fragments in such a way that all the three fragments are combined together to give this single vector. So this is the basic meaning of resolution of vector. Means if there is a vector in two dimensions, then it can be resolved into two one-dimensional vector, and if a vector in three-dimensional, then it can be resolved into three vectors of one dimension. Three vectors of one dimension. So we can say that resolution of a vector simply means if a vector is in two dimensions, it can be resolved in two vectors in one dimension, and if a vector is in three dimensions, it can be resolved in three vectors in one dimension. Means What is the meaning of saying this? What is the meaning of saying this? If there is a three vector, suppose there is a r vector, means you can resolve into rx and ry. There are two fragments of this r vector, and if there is a vector in 3 dimension, then you can resolve rx, ry and rj. Rx is the component of this vector which is representing along x-axis. Ry is the component of this vector which is representing a vector along y direction. Similarly, if r is in three dimension, then rx is the component of this vector along x-axis direction, ry is the component of this vector in y-axis direction, and rz is the component of this vector in z-axis direction. Now, we will see how we can resolve this. So we are taking the example of 2 dimension, and based on that example, I will try to explain you the resolution of vector. I am drawing it. This is y-axis, this is x-axis. This is y-axis, this is x-axis, and this is vector O. This is r vector, and we had resolved it along rx and ry. Rx and ry. This is ry. So this is parallel and equal, so it will be ry, and these are the two vectors. Then due to the triangular vector addition, r vector is equal to rx plus ry. R vector in xy plane. Orthogonal vectors. Orthogonal vectors. Rx vector and ry vector along x-axis and y-axis, along x-axis and y-axis respectively. Clear? These are the two components of r vector along x-axis and y-axis. So from law of vector addition, from law of vector addition, we can say that r vector is what? R vector is equal to rs vector plus ry vector. It is clear from the diagram also. R vector is equal to rs vector plus ry vector. Now, dear students, we had studied about unit vector. When we are discussing about types of vectors, then we had discussed about unit vector. And for any vector, a unit vector can be represented which represents the direction of that vector, and it is equal to vector A upon, suppose there is a vector A, the unit vector for vector A is equal to, so we can write it as vector A is equal to magnitude of vector A into unit vector. Magnitude of vector A into unit vector. So it is conventionally supposed that the unit vector along x-axis is I cap, the unit vector along y-axis is j cap, and unit vector along z-axis, unit vector along z-axis is equal to k cap. So here we no need to discuss about the unit vector along z axis, because we had taken r vector in 2 dimensions, means x axis and y axis plane, xy plane. So we can write r x vector is equal to magnitude of rx into I cap, because unit vector along x direction is I cap, and ry vector is equal to magnitude of ry into j cap. Now since vector r is equal to vector rx plus ry, vector r is equal to rx plus ry, so it can be written as vector r is equal to magnitude of rx into I cap plus magnitude of ry into j cap, or you can write it as rx I cap plus ry j cap, rx I cap plus, suppose this is equation number 1. Now, how the magnitude of resultant, because both are orthogonal, rx and ry, look at here, rx and ry, this is rx and this is ry, and they are making an angle of 90 degree with each other. So, the magnitude of resultant can be given by under root rx square plus ry square, rx square plus ry square, and this direction phi or theta, whatever you can say, so tan phi is equal to ry upon rx, or phi is equal to tan inverse ry upon rx. This is the angle which the resultant makes with the horizontal axis or x axis, that is phi. So phi is equal to tan inverse y axis, tan inverse ry upon rx, means whatever the resultant vector is making an angle with the horizontal. So from here one thing should be noted down, and what is the make it note down, if r is equal to rx, then ry is equal to 0. Means suppose this r vector is along this, means the component along y direction is 0. If this vector is coinciding with this vector, then there is no component of this vector along this direction. And if r is equal to ry, then rx is equal to 0. So component of a vector perpendicular to itself is 0. Component of a vector perpendicular to itself is 0. Suppose I am taking a vector r, and if I am saying what is its component along this direction, the answer will be 0. If I am taking a vector r in this direction and asking what is its component, then it is equal to 0. Means if there is a vector, then its component along the perpendicular side or orthogonal side is 0. So this is important discussion, students, and I hope that you had understood all these things. Try to recap and view these things to make your concept clear. So that's all for today, students. Now in the tomorrow's video we will discuss certain numericals based on this, and after that we will discuss about multiplication of a vector with a scalar, and then we will proceed for dot product and cross product for vectors. Thank you for today, students. Take care. Good night.